probably half minus 1, that only into dx upon dt equal to 1 here, because t is differential with respect to t, that means 1. Take dt to that side, it will be 1 upon 2 under root x into dx equal to dt. Take dt to, now dt is separate, as I will tell you that it's not a composite function here. Dx upon dt, they can be separated now. But previously we were thinking that dx upon dt, dy upon dx is inseparable, okay, or that is composite number. But that is not composite. We can take dt to that side. So this is what now. So, but here we are having 1 upon under root x into dx only. This is cos under root x means t. This 2 can be taken to that side. That means 1 upon under root x into dx equal to 2 dt. This is finally replaced. Okay, this implies that 1 upon under root x into dx, because this is 1 upon under root x into dx. Cos under root x, or can be written like this. Let me write here cos under root x into 1 upon under root x into dx. Now in place of this, we can replace this. This is cos under root x be considered as t, cos t into dt. Now it can be integrated. It is now integrable function. Now it can be integrated. Therefore, integration of this will be cos t is sin t, positive, plus constant of integration. Write constant of integration. T now replace t into the original value. T was under root x. We assumed this is sin under root x plus constant. This is the answer. The final answer is this. This is the process of solving this kind of question by substitution method. Okay, so now let me take question number 3. Now question number 3 says, okay, in the question number 3 here, the question number 3, sign of integration x square into sin x cube. Okay, now we see that differentiation of x cube is 3 into x square. So x square is there, x square into bx, we consider dt. So assume here, assume or let us assume, okay, x cube equal to t. Differentiating it with respect to t, we get 3 into x square into dx upon dt equal to 1, or 3, or let me take x square into dx equal to dt upon 3. Okay, so x square dx, it can be written as, or it can be written as sin x cube into x square into dx. Now it can be changed into the another variable, t variable, new variable t. This is sin t into x square dx equal to dt upon 3. That means 1 upon 3 is a constant. This is sin t into dt. Can be integrated as 1 upon 3. Sin t is minus cos t plus constant of integration. This is minus 1 upon 3 cos t. T means x cube plus constant. This is the answer here. So replacing t by x cube, but we assume x cube as t. Okay. Original value is in terms of x. This is the final answer. Okay, this is question number 3 we have done. Similarly, other questions we are going to do. Now, 1 or 2 maybe, but let me solve them just for the practice point of view, that one can get practice. Now, question number 4th one. Okay, question number 4th is sign of integration. This is twice x. This I just write, or let me write here 4 point. It looks like it is a minus sign, no minus sign. Only I just note down just like question number this. Okay, I'll note down here 4 point. Okay, I write here point only, that it doesn't look like a minus sign with this. Okay, so this is sign of integration, twice x into cos x square into dx. Again here x square, we have to assume that x square equal to t. Therefore differentiating it with respect to t, we get this twice x into dx dt because by function of a function method x is not t, so it will be differentiated as dx upon dt equal to t. We are referring to the respect of t, so t is 1. Take dt to that side, it will be twice x into dx equal to dt. Simple. It can be written as, first change it into the proper form. This is twice x into dx. Now it is replaced by dt. So it can be written like this. This is cos t into dt. Cos t is sin t, because constant of integration. Now substitute the value of t here, which is x square plus constant. So this is constant of integration. Final answer is this. Okay. This is question number 4 here. Now let me take the 5th question. Now question number 5th here. Okay, so question number 5th. Okay, let me write point here. Sign of integration. Question number 5th here. So what is this? X into, okay, x into sin x square into dx. Again we can write it as sin x square into x into dx. Obviously x square, assume that x square is t. Let x square equal to t. Twice x dx equal to dt. Just write down or differentiating this it with respect to t. Okay, just directly. Okay, if twice x dx upon dt equal to 1 or twice x dx equal to dt. Okay, so that can be replaced now. Therefore, this is sin x square is t. We have assumed x dx equal to dt upon 2. So here x dx equal to dt upon 2. Take to the other side. This is dt upon 2 here. This is 1.2 constant. Sin t is integrated. Okay, so it will be minus cos t. This is 1.2 minus sin cos t plus constant of integration. Now t is to be replaced by that variable, original variable. This is minus half cos x square plus constant of integration. This is the answer here. The final answer is this. This is how we have solved these questions. Let me solve all these questions so that one can get practice of this code. Now, the 6th question. Okay, so question number 6 here. What does it say? Sign of integration e raised to power x. It is cos of ex into dx. Okay, so consider ex as t, or can be written as cos of e raised to power x into ex into dx. So now let ex equal to t, differentiating it with respect to t. With respect to t, we get it is ex into ex, but x is not t, so this is dx upon dt is equal to 1, and ex upon dt equal to dt. So in place of this ex dx, we can write dt. It is cos of t into dt. Now it can be integrated. Integration of cos t is sin t positive, sin t plus constant of integration. Now substitute value of t here, which is ex. It is sin of ex plus constant of integration. This is the answer. Okay, so question number 6 we have done. Now let me take the 7th question. Question number 7 is sign of integration. Okay, this is x cube into cos of, sorry, it is cos of x4. Same question can be written as cos of x4 into x cube into dx. Let us assume that x4 equal to t. Differentiating it with respect to t, we just write this as equal to t. So this is 4x cube dx upon dt equal to 1, or x cube, because x cube is here, x t into dx equal to dt upon 4. In place of x cube, x cube, which one is x cube dx, we can replace dt by 4. We can replace it by dt by 4. This is cos of t, because x4 we have assumed as t, into dt upon 4. It is equal to 1.4 sin of integration cos t into dt. That means 1.4 into sin t plus constant of integration. Answer is 1.4 sin into x4 replace t by original value x4 plus constant c. This is the final answer. Okay, so question number, this is 7th question we have done. Now let me take question number 8 and the next question. Okay, so this is the process of solving integration by using substitution method. So substitution method is used like this. Okay, now question number 8 here. Question number 8, let me replace this. Question number 8 is okay, x raised power n minus 1 into sin of x raised power n into dx. We can change it like this. First write sin x raised power n into x raised power n minus 1 into dx. Let us take, let xn equal to t. Okay, we assume like this. Now differentiating it with respect to t. With respect to t, we get this is n into x raised power n. Now this is differentiation, but x is not t, so this is df dt equal to 1 here. Differentiation of t with respect to t is 1. Take dt to that side, so this is x raised power n minus 1 into dx equal to dt upon n. Take n to that side. Okay, because we are having here x n minus 1 dx equal to dt by n. Now therefore this is sin x raised power n. Okay, let me change this. So this is t here into dt upon n. Can be written as 1 upon n, which is constant. Take outside is sin t into dt. Integration is minus cos t plus constant of integration minus 1 upon n into cos t is replaced by xn, because our value was in terms of x. In place of t, we have to replace it by x raised power n initial assumption. Okay, so this is the answer. Final answer is this. This is answer of question number 8. So let me take 9th question. So question number 9 says, what is the 9th question? Okay, question number 9 is sin of integration. This is sin under root x upon under root x into dx. Okay, under root x, let us assume t. So we have to assume that under root x equal to t. Or we can write x raised power half equal to t. Square root means half power 1. Okay, so differentiating it with respect to t. Differentiating it with respect to t, we get half into x raised power half minus 1 into dx upon dt equal to 1. Or this is 1.2 into x raised power minus half into dx equal to dt. This is 1 upon under root x. For x raised power minus half means can be taken into denominator into dx. This is equal to dt into 2 into dt. 1 upon under root x into dx. So let me write it as properly. Sin under root x into 1 upon under root x into dx. In place of this, we can write this value. This is sin, this is t. We have assumed as t and root x equal to t. So this is now 2 into dt. 2 into this. This is take 2 is a constant. You can be taken outside or out of integration sign into dt. Integration of this is twice into minus cos t plus constant of integration. This is minus 2 t is under root x plus constant of integration. This is the final answer. Okay, this is the final answer here. Okay, so question number 9 we have done. Now let me take other questions. Question number now 10th. There may be some difficult questions as well. Let me take the 10th question. Question number 10th here. What is question number 10th? It says sign of integration. Sign of tan inverse x. Okay. Upon 1 plus x square into dx. Okay, so here again tan inverse x is equal to t because 1 upon 1 plus x square. You know this is differentiation of tan inverse x. Let us assume tan inverse x equal to t, differentiating it with respect to t, we get it will be 1 upon 1 plus x square into dx upon dt is equal to 1, or 1 upon 1 plus x square into dx equal to dt. So now in place of this we can write as, let me write it again, sine of tan inverse x into 1 upon 1 plus x square into dx. This is nothing but sine of t into dt. This integrated as minus cos t plus constant of integration. Now write down the value of t here. This is minus cos of tan inverse x plus constant of integration. This is the final answer. This is the answer here. Minus cos of tan inverse x. The final answer. This is question number 10. Now let us take other questions. Question number now 11th. What does it say? Question number 11th is, okay, this is cos of, okay, cos of log of x upon x into dx. Okay, so this is cos of log x. Now let's assume cos log x equal to t, differentiating it with respect to t. With respect to t, we get it is 1 upon x into dx upon dt equal to 1, or 1 upon x into dx equal to dt. So replacing this 1 upon x dx, or it is nothing but cos of, let me write it properly, 1 upon x into dx. In this way we can write down so that it looks easier or simple. Now replace that value. This is cos of t here into dt, because 1 upon x dx equal to dt here. Now it can be integrated. So this is sine positive sine t plus constant of integration. Now substitute the value of t here. This is nothing but sine of log of x plus constant of integration. This is the answer. Final answer is this. Okay, so this is the process of solving this kind of questions. Let me take other questions so that mastery of this topic can be obtained. Okay. Now, question number 10 we have done. 11, 12th question. Okay, so question number 12 here is sine of integration second square. Okay, this is log of, again, log of x upon x into dx. Okay, this is again log x equal to t. So these questions are similar type. Let again log x equal to t, differentiating it with respect to t, we get, we always like this. This is 1 upon x into dx upon dt equal to 1 upon x into dx equal to dt. So replacing this is or. Okay, replacing this. So this is second square into t into dt, 1 upon x dx equal to dt. Okay, or we can simplify like that. Now it can be integrated. Second square t is 10t. Simple integration, because differentiation of 10t is second square t. Therefore, integration of second square t is 10t plus constant of integration. Now replace t by the assumption. This is log of x. This is the final answer. Okay, so final answer is this. This is the process of solving this kind of questions. Now let me take the 13th question now. Now question number 13 is what? What is the question number 13 say? Okay. So question number 13 is sign of integration. It is sin x upon 1 plus cos square x. This is cos square x into dx. Okay. Now here we have to assume cos x equal to something. What is cos x here? Okay, so this is going to let cos x equal to t, because here it is cos x whole square. Cos x equal to t. Let now differentiating it with respect to t, we get this is minus sin x differentiation into dx dt equal to 1, or sin x into dx equal to minus dt here. Okay, what is that? So this is sin x dx minus dt, that means minus dt on 1 plus t square. Why? Because this is dt minus dt here. Now this is negative, minus 1 upon 1 plus t square, or 1 upon x square. It will be cot inverse t. It is nothing, integration of this will be cot inverse t. It's not sin inverse, tan inverse t, because it is negative sign. It will be, or we can write as minus sin tan inverse t. Then negative sign, we change it into cot inverse t plus constants. Now substitute the value of t. Is cos, or cot inverse. I'm sorry. This is cot inverse cos of x in place of t as a constant. This is the answer here. Here it was negative sign, so that this is cot inverse t. Okay, because if it is positive, then it is tan inverse t. Okay, so the answer is this. This is the final answer here. Now let us take the 14th question. What does the question number 14 say? Question number 14 says, what is that? This one. Okay. Now question number 14, sign of integration. This is sine of a plus b log of x divided by x into dx. So this whole value is to be assumed as t. Okay, so let us assume that a plus b into log of x equal to t. Now differentiating it with respect to t. With respect to t, we get, it will be a is constant 0, b into log x is 1 upon x into dx upon dt equal to 1, or b, and let me take here 1 upon x into dx equal to dt upon b, the constant. 1 upon x into dx equal to dt upon b. It will be sine of t, okay, into 1 upon b, that means dt upon b, that means 1 upon b can be taken outside or out of integration sign. Okay, so now integrate this. This is 1 upon b minus sine cos of t. So it will be cos of t, constant of integration. 1 upon b is minus sine. Replace t by original value, which is a plus b into log of x plus constant of integration. This is the final answer here. We have replaced this value. This is the final answer. Okay, this is a process of solving substitution method. Using substitution method, questions of integration. Okay, this is one of the important method which is to be understood by the student. Otherwise, they can't solve the questions. Get the mastery over this topic. Only then one can get this question to be solved. Okay, now let me take 16th. This question is now 14th we have done. 15th question now. Question number 15th is sign of integration e raised power x, e raised power sine inverse x, e raised power sine inverse x upon under root 1 minus x square into dx. Okay, again it's obvious that sine inverse x, so we assumed let sine inverse x equal to t. Differentiating it with respect to t, we get this is 1 upon under root 1 minus x. This is the integration of sine inverse x. 1 upon under root 1 minus x square into dx upon dt. Take dx to dt to this side because this is value 1. Take dt to that side. We have just taken one step ahead. Okay, so this is 1 upon under root 1 minus x square into dx. This is equal to dt. We can write it as e raised power sine inverse x. Let me just simplify this. This is dx upon under root 1 minus x square or 1 upon under root 1 minus x square into dx. That is given. This is sine of integration e raised power t into dt. Now integrate this. This is e raised power t plus constant of integration. Substitute the value of t, which is e raised power sine inverse t. Sine inverse t here is sine inverse x. Sine inverse x plus constant of integration. Now this is the original value in terms of x, because this answer is not proper, because some students leave up to this stage only. They do not convert t into the original value. That is the mistake. One solution. Okay. Understand this question. So this is the final answer. Okay, so this is the answer of question number 15th. Now let me take other questions. Now question 16th is what? What's the question number 16th? Okay, now question number 16th. Okay, is sign of integration. This is e raised power cos inverse x divided by under root 1 minus x square into dx. Okay, here let us assume cos inverse x equal to t. Now differentiating it with respect to t, we get here cos inverse x is minus 1 upon under root 1 minus x square into dx upon dt equal to 1. This is 1 upon, but here it is no negative sign. You have to take it as 1 upon under root 1 minus x square into dx equal to minus dt. Okay, so in place of 1 upon under root 1 minus x square, let me write it as e raised power cos inverse x into 1 upon under root 1 minus x square into dx. In place of this value, we write minus dt. It will give minus sign e raised power t into dt. So it's now integrable. This is minus e raised power t plus constant e raised power t, e raised power t integration. Now substitute the value of t. This is minus sign e raised power cos inverse x plus constant c. Now this is answer of question number 16th here. Question number 16th is solved. Now let me take question number 17th now. Question number 17, what did it say? Okay. Question number 17th is sign of integration x upon, it is 1 plus x4 into dx. Okay, now in this case, we can write it as 1 upon x, 1 plus x square whole square into dx. Now it's obvious that x square equal to, let's take t. Let x square equal to t. Okay, Therefore, differentiating it with respect to t, we get we get here twice x into dx upon dt equal to 1, or x into dx equal to, this is x into dx equal to dt upon 2. Take to this side, that side. It will be, okay, so x into dx numerator. This is t here. We write it as dt upon 2 means 1 upon 2. Take outside. This is 1 plus t square. So this is what? Now we know that integration of this is 1.2. This is tan inverse t. Okay, plus constant of integration. Now substitute the value here of t. What is t here? X square plus constant c. This is the answer unlike because the original value must be in terms of t only. So this is what answer is. Okay, so this is answer of question number 17. Now let me take question number 18th here. Question number 18th. What did you say? Okay. Question number 18th is sign of integration. This is 3x square. Okay. 3x square divided by 1 plus x6 dx. Okay, x6. Now we can write it as sign of integration 3x square divided by 1 plus x cube whole square into dx. No change. Now we can assume that x cube, let x cube equal to t. Okay, so x equal to t here. So therefore 3x square into dx dt, integrating this or differentiating it with respect to t, we get this one 3x square dx dt equal to 1, because x cube is 3x square and dx 1 dt. So therefore 3x square into dx equal to dt. Simple. 3x square into dx, in place of in the numerator we can put this. So finally the answer is dt upon 1 plus t square. This is t, so t is square. Therefore it can be integrated as tan inverse